Okay, so we come to the last part of this video on polymorphism, and in this video we're going to learn about how the virtual function works. Now before we actually talk about how the virtual function works, let's look at an example where we had discussed what a virtual function was, right? So a quick recap of the virtual function. Now using a virtual function we achieve dynamic polymorphism in C++. How do we do that? So when we write the keyword virtual, when you declare a function as virtual in the base class, then the binding of that function is not done at compile time, and the binding of that function is done at runtime. So whatever we wanted to achieve when the base class pointer points to the object of the derived class, it invokes the derived class display. So that's the whole point about what exactly polymorphism is. Now the whole question is, how does a virtual function work? Well, it's very easy to implement it. You just need to write the keyword virtual. But exactly what happens when you make a function virtual? How does the compiler actually invoke or help in invoking the function at runtime? So that's what we're going to discuss today. Fine, so let's start. So first thing is, there are two important attributes or characteristics or properties that a virtual function brings. Now, in order to implement a virtual function, you have two new concepts which comes into the picture. The first one is a virtual table, and the second one is a virtual pointer. Now, what exactly is a virtual table? So if there is a base class which contains a virtual function, and if that function also exists in the derived class, that means we are trying to achieve polymorphism, then what the compiler does is, for every class which carries that virtual function, an extra space is reserved in the memory for something called as a virtual table. Now what exactly goes into a virtual table? The virtual table consists of the address of the virtual function of that class. Now, for every class, one virtual table would be created. Now, virtual table, since it exists in the memory, it will also have an address. Now, here is where virtual pointer comes into the picture. Now, every time an object is created of that class, this object, along with its attribute, values and attribute, a separate memory location is also added in it, which holds the address of the virtual table of that class, which means that every object will have a slightly larger size now. So if you use a virtual function, what will happen is when the object is created, it will be created of a slightly larger size. Why? Because it is also storing an additional attribute, that is virtual pointer. What does a virtual pointer do? The virtual pointer stores the address of the virtual table, right? Now, so this is all fine, but how does it actually work? So let's look at a small simulation of how a virtual function works. Now we have two classes, say class A and class B. The class B is a derived class which is deriving where the base class is class A. Now if you notice here, we have two functions. One of them is display and the other one is show, and each of these functions are declared using the keyword virtual, which means that these two are going to be called at runtime, and the compiler will not do a compile time binding. Now derived class B has also got a display, which means the display of class A should be overwritten by display of class B in the derived class, right? So since this is virtual and this display translates to this, two virtual tables will be created, one for class A and the other one is for class B. All right, now let's look ahead and see how exactly this works. Okay, now we are not writing the classes down, because class we've already understood what happens on the top. Now let's look at the main method. Now in the main method, the first step is I create an object of the base class. Along with that, I have created a pointer of the base class. Now this P is going to be my remote control, which is going to help me in polymorphism. Now what exactly happens here? So we have an object A. Now A is an object which will have an additional memory allocation for storing the virtual pointer, right? And what is this virtual pointer? Virtual pointer will be the address of the virtual table, which will consist of all the address of the functions. So if you look at it, A will be an object which will contain a small additional memory for a VPTR, which is a virtual pointer. This virtual pointer will be pointing to the virtual table. Now in this virtual table you have two things. One is display, which will be the display of A, and the other one is show, which will also have the address of the display show of A. Right? Now let's move ahead. Now we create another pointer variable P. So this is what is happening in the first line of the code. Now let's create another object. So when you create object B, now another object B will be created with a virtual pointer, and this virtual pointer will be pointing to the virtual table for the class B. So let's look at it this way, right? Now if you look into the virtual table of class B, you have display, which is going to be the display of B because it is overwritten, and we want to implement this display of class B. We want to override the display of class A in class B. So if you notice here, you have and B display this here, which means that we are in the virtual table, we are storing the address of display of class B. And since there is no show method in class B, the show method of class A will be inherited from the base class. So accordingly, the virtual table, the addresses, just remember that virtual table stores only the address of these functions, and which function it will store, that is very clear here, because we want to override it. So there is the addresses of the derived class display, and here there is no show in the derived class, so obviously the derived class the show of the base class is going to come here. Now this is what happens when we create an object of class A and object of class B. Now let's try and do polymorphism. Now what happens? First, when we take the pointer of the base class and point to the object of the base class itself, what happens? This pointer will point to the object of A. Now when this pointer is pointing to the object of A, this A object contains a VPTR which knows the address of only these two functions, which is display and show. So whenever we are going to invoke P display, it is going to invoke the display from the base class because the address of the display of the base class is mentioned in the virtual table. So basically the pointer P invokes an object A which knows the address of the display of A, and that's how the display of the base class is invoked. Now what we do is we take this pointer and point to the object of the derived class. So when we point to an object of the derived class, this is what exactly happens. Now if you notice, the object of the derived class has a virtual pointer, and this P, which is pointing to that object, knows only two functions from the virtual table. Which are those two functions? It knows the display of the derived class and the show of the base class. So if the pointer P invokes the display now, which display will be called? It will be the display of the derived class, not the base class, because look at the connection here. P is connected to B, and B knows the display of the derived class. So this is how the display of the derived class is going to get invoked if you invoke P display, right? So this is how exactly polymorphism in C++ is carried out, and this is exactly how virtual pointer and virtual table help behind the scene in order to achieve polymorphism. So hopefully you have understood how a virtual function works and how two extra elements come into the picture when we are implementing a virtual function, that is a virtual table and a virtual pointer. So just another point that I would like to make. Remember that there is only one virtual table created for a class, and the number of VPTR or the virtual functions will depend on the number of objects. So if you create 10 objects, you will have 10 VPTR, right? But the virtual table will always be 1. That's an important point. Just keep a note of it. Now, we have something called as a pure virtual function. Now, what exactly is a pure virtual function? Let's look at it. Now, a pure virtual function is like a virtual function, but in this case, what happens when you write display, you can write a body for that display. So in class A, if you want to write display, you have declared it as virtual, but you can also write a body for it. That means you can write an implementation of display, and you can also create an object of the class A. Now, effectively, when we are using a base class and we want to achieve polymorphism, we should avoid writing a body for it, because this display, we should use it only for creating a button on the remote control. Please refer to my earlier videos if you're having a problem in understanding what I mean by button on the remote control, right? Also, we should not allow anyone to create an object of A. Now that's important, because what's an object of a generic class? What's an object of an animal? How does an animal object look like? Again, please refer to my previous video, right? So how can we ensure that the developer does not write any body for that function, and also he or she is not allowed to instantiate that base class? Now, in order to do this, we have something called as a pure virtual function. A pure virtual function is a dummy function which does not have any implementation. They have null body, that means you cannot write anything in it. It is just used to create a remote control. They need to be overridden, that means yes, you have to write an implementation of that function which you are declaring it as a pure virtual function in your derived class. Also, if you have declared a pure virtual function in your class, obviously a base class, you will not be allowed to create an object of that base class, which makes sense, and that's what we want to do. As per a good design, we should not be creating an object of the the base class, right? So how do you write a pure virtual function? Very simple. Just declare a function as virtual void display, and all you need to do is equal to 0. Now here, remember, very important, that the function is not assigned a value 0, but it's an instruction to the compiler that this function is a pure virtual function without any definition. And if a pure virtual function exists in a class, right, then that class should not be allowed to instantiate, which means I cannot, or I will not be able to create an object of that class. Now, if you have a class which consists of a pure virtual function, that class cannot be instantiated. Now, in Java, classes which you cannot instantiate are called as abstract class, and the methods that you write, which is like a pure virtual function in Java, is called as an abstract method. So pure virtual function in C++ maps to the abstract method in Java, right? And if you have a class which you cannot instantiate, then that class is called as an abstract class. So that's all it is. So if you look at a pure virtual function here, let's look at a small example. And in this case, I have created a base class and I've created a derived class, right? In the base class, I have defined a virtual function here, which is a pure virtual function, right? And this, I need to make sure that I write an implementation for this in my derived class. So I create a base class pointer. Now mind you, since there is a virtual void display here, which is basically a pure virtual function, you cannot instantiate this class. So you cannot instantiate this class, the base class, because I have declared a pure virtual function. So if you try to create an object of the base class, it will throw an error. But can we write an object for the derived class? Yes. Can we point the pointer of the base class to the object of the derived class? Yes. So what is going to happen if you point to the derived class and invoke the display method. So in case you do that, then if you invoke the display method, this display is going to get triggered. So we achieve polymorphism, and we also ensure that the object of this is not allowed and no implementation can be written for this function. So that's more or less what we the properties of a pure virtual function. So now I told you about what's an abstract class, right? So let's have a look at it. An abstract class is a class that is designed to be specifically used as a base class. An abstract class contains at least one pure virtual function. You can have more than one, but it should contain at least one. Abstract class cannot be instantiated, and derived classes without virtual function is called as concrete classes. So if you don't have an abstract class, it's a concrete class. What is a concrete class? A class whose object you can create, or classes which can be instantiated. So that's the difference between abstract and concrete class. You can go through it. This is a very simple example again. So this is how abstract class looks like. So if you have a shape class, you can derive a circle out of it or a triangle out of it. You can't create an object of the shape, but yes, you can create an object of the triangle and object of the circle. Because if I ask you to draw a shape, you don't know how the shape looks like. It could be anything, right? So you should declare it, because it's a generic thing. A shape is generic in nature. You should declare it as an abstract class and put a pure virtual function there. So when you put a pure virtual function, you cannot create an object of the abstract class shape, which makes sense. But yes, you can inherit from that class, and you have to write your own implementation of the pure virtual function. In this case, it is area, right? And then you can instantiate these two classes. Now that's more or less what what polymorphism is. Important point again to be noted, that without inheritance you can't do polymorphism. And there is one more small thing which I probably explain it to you. And this small property which I'm going to explain to you is called as object slicing. Now, why it is important and why I have included into your syllabus, it's because this is a question which may be asked in your placement interviews, right? What will happen if you take two classes, in fact two objects, one is a base class object and a derived class object, and you take a derived class object and you assign it to the base class object. So what exactly does it happen? What exactly happens? Now you know that the base class object is smaller than the derived class object, because the derived class object consists of the base class as well as the derived class properties. So obviously the size of the derived class object is going to be larger and the size of the base class object is going to be smaller. Now if you assign the larger object to the smaller object, two things happen, right? You cannot fit in the large object into the small object. So what do? We cut that object, and then that part which is common to both the classes, right? That part, that property, we replace it. So this is called as object slicing. So if you look at it, I've created an object of class A, that is X. I've initialized the value 10, right? Similarly, I have B, which there are two values, 40 and 30, right? And I'm doing X is equal to Y, right? So what happens is, in the derived class object you have the component of A. So in this case, the component of A is 40 in the derived class and the component of A in the base class is 10. Now when you do X is equal to Y, the large object Y is sliced, and the component which is AA, which is common in both, the component of the attribute A, the integer A and integer B, the integer A of both the classes, that means 10 is integer A from the base class and 40 is the integer A of the derived class. So this value of 40 will get replaced in the base class A. Okay, so when you print x dot A, earlier the x dot A value was 10, but now the x dot A value will become 40, because this 40 from the derived class gets translates into or flows into the base class. Now this property of assigning a derived class object to a base class object and slicing the derived class object to remove the part which is not present in class A and replacing the value of the derived class into the base class object is called as object slicing. So you don't have to really rack your brains here. It's just a simple concept, and I want you to remember it not for any specific reason other than your placements, right? So with this slide we have come to the end of polymorphism, and I hope you really understand this well, because I have covered it in a lot of details with 5 videos, and I've done it very slowly, step by step. So the reason I did this was because one of the most important chapters in C++, and in your syllabus now all your major components of your C++ are over, and what we have, the other chapters, we will be doing it slowly and they will not take much time. So please go through all the videos from part 1 to part 5 of polymorphism and make sure you understand that. So I will see you in the class now. So take care. Bye bye.